I wanted to introduce our presenter, Julie Hagan, who is an experienced software testing practice manager with Lighthouse Technologies with over 20 years of software industry experience. Julia serves on a number of global multi-million-dollar large-scale software initiatives and implementations. You'd be hard-pressed to find anybody who understands software testing as well as Julie does. She's also very skilled in business development and practice management, and excels in tailoring processes to a metrics-driven, risk-based methodology. So without further ado, allow me to turn it over to Julie Hagan. Julie?
Thank you, David. It's a pleasure to spend time with everyone today. I really appreciate you taking time out of your busy schedules to spend it with us. As David mentioned, this is part one of a two-part webinar series. Part two will be in October, and we'll talk about that before we close. But it's based on what we refer to as the three perils of software development. We're beginning today with defects, which is a topic I'm very passionate about, especially when it relates to the problems that they can cause to your software projects. So I hope you find it valuable. So as project leaders, I find that we're often asking ourselves these questions. If you've led very many projects, you know that often, despite all of our best efforts, they overrun budget. And it can be a frustrating thing to understand why. So as we began here at Lighthouse digging into that topic, we began to look at defects and start connecting the dots, really, between what defects specifically as a driver can do to a project and the cost associated with it. So as part of that process, we spoke to literally hundreds, I think, of executives and project leaders, as well as drawing upon our own experience. And we found that it really boils down to three things: defects, which we'll focus on today, delays, and dollars. So we'll be talking about specifically dollars and what kind of overruns we can see from some of these perils to our projects. So let's start with a fun little exercise to kind of get our brains moving and get our brains ready for the topic. So I've got a slide here with three numbers on it: 5, 10,000, and 3 million. So what I'd like us to do is to take just a few seconds, 10 seconds or so, to make a mental note of what these numbers might mean in the context of defects, or if you're sitting at your desk, maybe just jot down a couple thoughts on what these numbers might relate to. And it'll be quiet here for just a few seconds while I let you do that. Okay, so in terms of the numbers and what they mean, 5 is really a multiplier. So we know that defects become 5 times more expensive to fix every time they leak from one phase of the software development lifecycle to another. In terms of 10,000, this is how many defects, believe it or not, that Lighthouse has seen in a client's production system. So let's let that word sink in for a minute. Production system, 10,000 defects. So you can imagine the havoc and the cost that many defects can wreak when we're talking about a production environment. Now, it was a large system, a complex system. That's a pretty big number. 3 million is how much it can cost you when just as few as 100 defects even, which in a large system may not really seem like that many, can cost up to $3 million to correct once those defects have made it all the way to production. So because of these kinds of numbers, we know that defects is a compelling topic. It's something we want to understand how to not only detect but to prevent defects before they cause these problems in our projects. Which leads us to our first peril and the reason why we're all here today. So let's talk about some root causes. So we all know that we hate defects and we want to prevent them. But let's back up a minute and take a few minutes to talk about where they actually come from. They come from many places. Firstly, they may come from a lack of resources. So everybody's pressed for resources. So let's talk about why that happens and why it's important. So how do you even know how many people you need for a particular testing project or engagement, right? So there's a lot of variables that go into that. You need to understand how large the solution is that you're going to be testing, how complex the solution is that you're going to be testing, how many test cases you need based on those two things, how long it might typically take your particular team to execute a test case. So you can see where this can right away go off track very quickly just by not understanding the number of resources required to provide adequate coverage. When we don't have adequate coverage, we introduce defects. Sometimes we have enough people, but we don't necessarily have the right people. And again, that happens for a multitude of reasons, right? Sometimes we have developers doing the testing for many reasons. Sometimes we have our SMEs or business users doing the testing. That tends to happen because SMEs hold a lot of expertise. They hold a lot of domain knowledge. They know their process, so they know where it's likely to break. But they tend to get focused on just their process and don't always understand the methodology that goes into ensuring appropriate coverage for the entire solution as a whole. Oftentimes, and I know everybody on the line can relate to this, defects come from poor requirements. So why is that important? Well, poor requirements become poor design, right? And then poor design, becomes poor code. And then often those things aren't found until we get to the test cycle where they've become much more expensive. So it's a big driver of where they come from. Often we have good exit criteria maybe, but that exit criteria isn't followed. Many times for business reasons that feel like they're good reasons. Maybe we've got a solution that needs to go to production and maybe it didn't quite meet the quality parameters that we were looking for in our exit criteria, but we need to get it out. Maybe there's revenue depending on the new solution hitting the market. Maybe it's an e-commerce site and the holiday season is coming up. So those feel like good reasons to go ahead and release, even though we didn't hit our exit criteria. But what happens then? We refer to it internally here as a new car in a hailstorm. So we get this nice, new, shiny product out there on the market, but it's full of dents because all of that hail, in terms of all the defects that we missed because we chose not to hit our exit criteria, is denting up that new car, and the customers are finding those dents. So now that we've talked about where defects come from, let's talk just at a high level about maturity. The point of testing maturity is that we want to move from a process where we're about detecting defects, which is important, but we want to move towards preventing those defects. Why? Because of that multiplier we talked about, the 5x. So we can prevent them before they leak and leak and leak and become more expensive. So the TMMI model, testing maturity, was really founded after the CMMI model, that we often use to measure the maturity of development organizations, applicable to a testing role or a testing organization. So I'm just at a really high level going to hit on some of the characteristics of each one of these levels, just so you can informally kind of assess where you are. If you know where you are, then you'll start to understand what the big rocks are that might cause you to get some improvement pretty quickly. So in a level 1 testing maturity organization, testing is ad hoc. You really don't have any processes. It's an afterthought. It's not discussed much until code is complete, and then there's a scramble to figure out how we're going to test it without having really anything written down. Sometimes that can be successful if you have some really heroic people in your organization that work well together and have been there for a long time. But often you'll find that that success won't be repeatable because there's nothing consistent about it. There was no process. There's no dedicated test team in a level 1 organization, and budgets tend to overrun quickly. In a level 2 kind of organization, you start to see testing become separate from what I would call debugging, so it begins to separate from developers. Some processes begin to exist, but they're not consistent across the organization. And each project is likely to kind of adapt whatever processes might exist to their own needs. So you become with a lot of disparate, inconsistent processes across the organization. And testing is still an afterthought at level 2. It's happening very late in the development life cycle, after a lot of money has already been spent on those defects leaking from phase to phase. Moving up the maturity model to phase 3, testing has become more of a separate organization and team at this point. It tends to be viewed as its own profession, meaning that training exists. And now we see testing start to move to the left across the software development lifecycle. So testers are actually involved now at the user story or requirements phase, and they're getting an opportunity to inspect those things and find issues with them before they leak. At level 4, we're starting to really get mature now, and we're starting to peer review test artifacts. So the whole team is maybe peer reviewing test cases that are written. They're holding each other accountable for process adherence and standards that have been put in place. And now improvement can be monitored because we're measuring some test team efficiency and effectiveness at this point. And then all the way up there at level 5, now we're predictable. You know, we've gotten to a point where our processes are down, we know how to adhere to them, we have governance in place to make sure all of that happens, and we can measure continuous process improvement there. So it's really all about moving, like I said at the beginning, from defect detection over to defect prevention. So give some thought based on just those high-level comments to where you think your organization might be as we move through the rest of the presentation. Okay, so we've talked about where defects come from, and we've talked about what a maturity scale might look like for a testing organization. But let's talk about what we all really want to know, which is how do we eliminate these defects? We typically know where they come from. We're frustrated by them, and despite our best efforts, we sometimes can't seem to get rid of them. So let's talk about eliminating them. So it's really a methodology around people, processes, and tools. So we know that 65% of improvement in any organization will come from your people. So think about what kind of folks you have doing the testing in your organization. Is it developers? Is it subject matter experts? Do you have a defined test team? Would you classify your testing resources as professional testers? Using professional testers can go a long way to eliminating your defects. And that doesn't mean you take your existing folks and throw them out and go hire all new people that are professional testers, right? Look for people within your organization that have the right aptitude and the willingness and the passion for testing and turn them into professional testers through a combination of training and mentoring. They can be grown. Secondly, we know that 25% of improvement will come from process. There are lots of things that go into process, and so I'm just going to spend some time hitting on a few of those today. Think about your planning process. Do you know how many defects are likely to be in the solution you're testing? And if you don't know, how might you begin to know? There are tools on the market. We here at Lighthouse have developed our own several years ago. We have a code analyzer that tells us the quantity of code as well as the complexity of the code, where the code is more likely to have risk associated with it due to the way it was built. And that allows us, along with looking at the maturity level of the development team that built it, to begin to understand how big it is and how many defects are likely to be there. When you know how many defects you're shooting for, it's a powerful tool for any test team because you have a target that you know that you're trying to reach. Look at making your processes repeatable. Often we work with organizations and their teams have the best of intentions, right? Everybody wants to do a good job, but they're flying by the seat of their pants. They don't necessarily have any written down guidelines about what does a good test case look like? What are the elements that should be there? Things like preconditions and postconditions. What level of detail should I have in my test case? What's too much? What's too little? Where's my data going to come from? What happens when those guidelines aren't set is that people start making it up. It's human nature, and they're going to draw from their experience and what has worked from them in the past to do that, and you end up with chaos. And when we have chaos, we will introduce defects every time. Take a look at your tools. Tools are meant to enable a good process. They're never going to be the magic bullet, so that's why we say look at tools where applicable, but they can be helpful. So maybe your organization is ready for a good test management tool that will help requirements traceability or user story traceability, for example. Maybe you need some stricter defect management with some good workflows behind it. If that's the case, you want to take a look at some defect management tools. And finally, automation. You have to be careful with automation, because if your organization isn't ready for that, then you can whittle away your ROI very quickly. But definitely put it on the table and take a look. Are we ready to automate? What should we automate? Where's the ROI? You will shorten your test cycles and you will increase your coverage for sure, which will be another step towards eliminating these defects. And then finally, metrics. If you're not paying close attention to metrics in your organization, then I would highly encourage you to do so. Some of the ones that we like to use here at Lighthouse are the ones that give us leading indicators that a project is going off track, so it's going to find itself on the rocks. So think about things that are going to give you an early indication of trouble. For example, one of the things we look at is defects by phase injected. And the reason we do that is because if we can see that we're injecting the majority of our defects in the requirements phase, then we know we have to do something different with our requirements management process in order to improve that. We also look at a metric that we call mean time to defect. So what does that mean? That means if you look across your entire testing organization, how often is it taking the team to find a defect? Early on in a testing engagement, you'll expect to find them pretty quickly. You know, the team might be finding them, every 15, 20, 30 minutes. But as the solution stabilizes and time passes, you can expect that time frame to widen, right? So when you get to the point where it's taking 8 to 10 hours for the team to find a defect, then you know you might be getting a little bit more stable. I would caution you to view metrics in combination, so almost as a balance. So you look at quality metrics as well as effectiveness metrics. The power in that information is when you can combine the information to tell a story. And it's the story that's going to tell you if your project is hitting the rocks and going off track. So think about how to use the information, what some leading indicators might be to let you know that your project is in trouble. So if you can do those things, you can really improve your DRE, or your defect removal efficiency. So I'm sure many of you track that today, but for anybody who may not be familiar with it, that's really a measure of how many defects are found and removed in a typical phase of the software development lifecycle. So a lot of organizations track it kind of at the end, how many did we miss, how many went to production. We like to track it by phase. So we know, how many were found and removed in unit test versus how many were found and removed in system test. And we'll talk a little bit about the power of that and why that's important. Many organizations find themselves in an 80% DRE. I think everybody wants to do better than that. 95 is a great target. In some industries, it's not good enough, particularly military or healthcare will want to find themselves, more in the 98, 99% range. So let's talk about an example that Lighthouse came across a little while ago. So we worked with a client in Europe. It was a very large European retailer, and they were building a new e-commerce site, and for very good reason. The holiday season was coming up. They really wanted to hit that holiday season with their brand new site to drive revenue and brand loyalty up to a higher degree, right? So some important business goals there that I think many of us share. So they were using an offshore developer for the development of their website, and they were expecting to find about 200 defects in system test. So Lighthouse got involved to help them execute that system test, and what we found, and this is really an example of the power of metrics, because we were able to track and understand the number of defects being found in unit test by the developer, we were able to project that in system test we were likely to find far, far more than the expected 200 defects, because the third-party development team wasn't removing the amount of defects that they needed to be removing during the unit test phase. So why do we care? Why was that important? Well, when we can project how many defects we're likely to find, then we can plan our test coverage appropriately. So we can stay on track, meet the schedule. We ended up finding nearly 1,000 defects, so 5 times more than what was expected in the initial stages of that project. 293 of those critical. So it's a little bit of a good news, bad news story, right? I mean, the good news is that all of those defects were found and we were able to adjust resources appropriately to find them before they went to production. Unfortunately, this client did not meet their holiday season deadline, but if they had gone out with such poor quality, it would have been a disaster. So, you know, definitely a success story here. So why do we care? Well, we know now, because we've connected the dots, that there is a strong correlation between defects and dollars. So as project leaders, we need to control our project cost. So what impact do these defects really have on our project dollars? Well, industry data tells us that the average cost overrun for a global, so large, IT change initiative is 27%. Already a pretty significant number. But of those, 1 in 6 will overrun by an average of 200%. Huge number. That's a number that causes projects to fail, that causes projects to be canceled, and people to lose their jobs for initiatives to go under. So it's a very important number to pay attention to. So what can we do? So we've talked about some key ways today to keep our project on budget and how controlling defects can help us do that. So of course we want to reduce them by many of the methods we talked about today. Have a good plan. Have an objective planning process that allows you to understand where the risk is in your solution, how large the solution is, how many defects are likely to be there, and what it's going to take to find them. Inspecting requirements. As we get more mature, we should be able to inspect those and understand what a poor requirement looks like compared to what a good requirement looks like. When we're looking for good requirements, we need them to be unambiguous, right? We need them to be concise. We need them to be testable. We need them to be consistent. So making sure, taking the time to make sure that we don't have a requirement or user story that completely contradicts another requirement or user story in the same solution. It's going to allow us to prevent defects versus detecting them. Test early, so move your testing towards the left. Get involved in user stories. Make sure you're involved in requirements. Log defects against them. Put in a real closed-loop defect correction system to make sure that those defects are getting resolved and documented as resolved before moving on to a design or coding phase. Automate whenever you can. Make sure you're ready. There are lots of organizations, Lighthouse is one of them, that can help you understand when is the right time to automate, what to automate, where you're going to achieve the best ROI, and what might be the best toolset solution for your organization and circumstances. And finally, minimize hidden cost. What do I mean by hidden cost? What kind of hidden cost might we have? Onshore outsourcers help mitigate hidden cost by as much as 65%, and let's talk about why. So for many years, offshore solutions have been looked at as a way to lower cost for valid reason, right? It's no secret that bill rates are much less than typical onshore bill rates in the U.S. But let's take a closer look. Let's begin to peel the onion a little bit about what these costs really look like and what costs might be hidden, so to speak, in an offshore solution. So if you take a look at my chart here, you can see a typical offshore tester bill rate of $28 an hour versus an onshore type bill rate. We've included lighthouses here because that's what we know, of $45 an hour. And you can see for an offshore test manager and on-site manager, we've done the same kind of cost comparison. But let's look below the line at the client cost, because that's really where the hidden costs tend to be. It takes about 25% more of a project manager or project management effort in order to manage an offshore team. It's just simply more difficult to do. So it's a cost that we shouldn't ignore, that we need to pay attention to and do our best to quantify. Similar to that, we have development rework that is introduced when we're working with an offshore partner. For many reasons, for communication challenges, time zone challenges, cultural challenges, simply do drive more rework based on all the clients and executives and project leaders that we've spoken to. So it's another cost that we need to account for. So when you take those things into account, the additional project management as well as the additional development rework that can be seen in an offshore model, the costs really aren't that different after all. If you take that into consideration, then an onshore solution is likely worth looking at when you're looking at reducing your project dollars. So what do we want to take away from today? What are the most important things? Well, to me, the very most important thing that I want everybody to understand is that these project failures are avoidable. We don't have to be stuck in that rut that we often find ourselves in of swimming upstream with no end in sight. We can put real, tangible people, processes, and tools in place to avoid those failures. If you do nothing else, find your way to a predictive metrics-based methodology. You can't manage what you don't measure. So understanding what your plan's going to look like, why it's going to look like that, what's the real scope, how long is it really going to take, how many defects should you be finding, and be able to measure against that with leading indicators of going off track is key. Supplement testing where you need to, both with automation, if readiness shows that that's appropriate, and use cost-effective onshore partners. And I realize that maybe not every onshore solution is cost-effective, but take into account the chart that I showed about what those hidden costs really look like and evaluate that accordingly. And then take a look at your current state. Try to be objective. Where are we as an organization? How do we do our testing? If I had to informally pick on that TMMI scale, where do I think we would be? And then, think about a roadmap. What are the gaps I could close right now in the next 4 weeks even to make a real change in my organization? It's all about being proactive. If you can reduce defects, then you're going to reduce dollars lost, which is going to have an impact on all those budget overruns that we discussed. And I'm going to go ahead and open the floor for questions.
So thank you, Julie. Great job. We did have a couple of questions come in during the course of your presentation, but also wanted to encourage everybody to use the chat feature on the left if you have an additional question that we're not going to ask here. So first one is, I see what you're saying about defined, repeatable process, but how do we get started?
That's a great question. So you really get started by either taking a look yourself or engaging an objective, qualified third party to help you. Do a quick assessment. understand where you are so you understand where you need to go. So often big rocks fall out pretty quickly. Maybe you don't have defined test cases, maybe you don't inspect requirements. You might have a process written down, but possibly nobody follows it. Those are the kind of things that are going to come out of a quick assessment, and they're things that can be addressed right away. So typically, a roadmap falls out pretty quickly. So these are the top 5 things that we can address in the near term. Here's the other 3 things we can address in the longer term, so maybe 6 to 12 months, that are going to give us the biggest bang for our buck, so to speak, and give us an ROI around change.
Okay, excellent. So another question came in. Can you suggest any specific automation test tools?
Automation tools really depend on what you're trying to achieve. So you have to think about what your objective is with automation. What's your development methodology? Are you more waterfall? Are you more agile? Are you a hybrid? What are your time to market requirements? What's your cost? What kind of budget do you have to invest in tools? Those are going to drive whether a commercial tool versus an open source tool are appropriate, and what kind of combination you might need to have. Open source tools are really a framework, so there's an interesting kind of blurb about them that floats around in the industry, and that's that they're free but not cheap. So if you're going to go with an open source tool, you have to think about the technical expertise you might need to acquire in your organization to be able to make that successful. So it's really dependent on several variables in terms of what automation tool you should use.
Okay. You also spoke, there's a question, you spoke of predicting the number of defects to be found in a project. What are the algorithms you use to predict this number?
Great question. So we look at several things. So we look at the size of the code in terms of function points. We look at the complexity of the code and where that code might be the most complex. We look at the CMMI level of the organization that did the development. That's important because we know that a CMMI level 1 team, for example, will inject more and remove fewer defects than a CMMI level 3 organization. It's very important to take that into account because it will drive the amount of retest and regression that needs to occur. So if you don't include that in your plan, then you're going to go off track really quickly. Let me backtrack, David, to your question about test automation tools because I failed to give a few examples. Over on the commercial side, HP, UFT is still the market leader. Many people have been moving away from HP due to cost, but it's still a big tool in the market, so you should at least consider it if you're looking at commercial tools. If you are doing Oracle test automation, their product Oats is gaining a lot of traction in the marketplace. It comes with a lot of pre-built content that makes the job easier. Over on the open source side, Selenium, as we all know, is very popular, but there are other tools popping up in that space as well, such as SoapUI and a few others.
Okay, great. I know you covered this off a little bit earlier, but there's a question that came in. You say defects can be caused by poor requirements. How can I tell if our requirements are poor or not?
Good question. We use an IEEE inspection process. So really you're asking yourself questions about each requirement. Is my requirement testable? Is it unambiguous? Is it concise? Is it consistent? Is it traceable? Can I trace it to something that's testable, or can I trace it to something in the design or the code? So if you can answer yes to all of those questions, then you probably have a good requirement. If the requirement fails inspection, then what we do and what we encourage our clients to do is to log real defects against those requirements so that they're tracked to closure. It's really not enough to just kind of informally mark them as bad and hope somebody fixes it. They really need to be tracked and traced to closure.
Great.
We also employ, I'm sorry, David, we also employ peer review, which really raises our quality. So we have business analysts here in our organization as well as testers. So when they write requirements, not only are they being formally inspected, but they're being peer reviewed as well. So, the other folks on their team are taking a look and giving their input. And we do it with all of our test artifacts, test cases, test planning documents. We peer review everything.
Excellent. So we have no more questions at this time. I did want to encourage everyone to sign up for Part 2 of Keeping Your Software Projects Off the Rocks. And Part 2 is related to delays, which is the second piece of the three-part Three Perils. That is coming up on Wednesday, October 7th. And when we send out the archive of the webinar here today, we'll also include a link so you can go to the sign-up page if you like. And we actively encourage you to do so. I think it'll be well worth your time. And as an added feature here, if you have any questions or would like to discuss further the content of this webinar or your specifics related to your organization, Julie Hagan, who just did the presentation, is available at 937-458-0055, extension 328. She'll be available for the next hour to take your calls, or immediately after this webinar, I should say. And Jeff Van Fleet, our illustrious CEO, is also standing by to take your call, and he's at extension 201. So we hope that you take advantage of that. We also hope that you found this particular session, this particular webinar, beneficial. I found it exciting myself. And that's pretty much it for today. Thank you for attending. And once again, as a follow-up, you can call Julie or Jeff. They're standing by to take your calls. So thank you very much, everyone. Have a great day.
Thank you.